Hi, class. This is Professor Smith. I'm going to be doing a movie on finding a specified term of a geometric sequence given two terms of the sequence. So before we attempt to do this problem, let's discuss what is a geometric sequence. Well, it turns out if we select this link, they give an example of a geometric sequence. They give the definition too, but I'm going to go to the example and then we'll come back and take a look at what they have written in the general form. So for example, we have the 2, 4, 8, 16, dot, 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 2 to the n. A geometric sequence is a sequence of numbers in which when you divide two consecutive values, you get the same ratio or the same value, which we call the common ratio. So if you take 4 divided by 2, you get 2. 8 divided by 4, you get 2. 16 divided by 8, you get 2. If you take 2 to the n divided by 2 to the n minus 1, you also get 2. And you're thinking, well, wait a moment, how does that happen? Well, the 2 to the n's cancel, and you have 1 over 2 to the minus 1, which means if it's negative, you reflip it. So each value is 2 when you do the division. So R is called the common ratio. Here's another example of a geometric sequence. If you take 1/3 divided by 1, you'll get 1/3. 1/9 divided by 1/3. It turns out when you have a complex fraction, 1/9 divided by 1/3, that's equivalent to doing 1/9 times the reciprocal of 1/3. So that's equal to 1/9 times 3 over 1. And then the 3 over 1, 3 over 9 can cancel, and you have a 3 in the denominator, so it's equal to 1/3. So you can see, oh, it is the same ratio of 1/3. And the first term, A1, is equal to 1. So here's an example where the first term is equal to 1/3, the first term is equal to 1, and the ratio is equal to 1/3. In the previous example, the ratio was 2, but the first term was also 2, and that's not always the case. So we just want to show you two examples. So R was 2 in this example, and A1, which is the first term in the sequence, is also 2. So let's go back to our problem and, oh no, sorry, before we do our problem, there is a general form when you have a geometric sequence. And so the general form says here that if you have A1 and R, I can tell you what the form of the sequence is going to be. So for example, let's say in this one here, we wanted to figure out that we have the first term, the second term, the third term, the fourth term. Let's say we want to do the fifth term. This general form says, look, if you want the fifth term, just take the first term and multiply it times R, the common ratio, raised to the 5 minus 1, which is 4, power. So let's do that. Let's find that fifth term. So if we do A5 is going to equal 1 times the common ratio, which is 1/3, raised to the 5 minus 1 power, and 5 minus 1 is 4. And then we're going to get 1 over 3 to the 4th, which is 1 over 3 squared, or 1 over 9 times 9, and that's 1 over 81. And you could also use your calculator, and that would be our fifth term. All right, so now that we have our general form for our geometric sequence, this is also called closed form, that's going to help us in solving the problem. So let's go out and do the problem now. So let's clear our drawings. And solve our problem. So in this example, we're given a geometric sequence. The first term is A1 is equal to 41 over 9, and the fourth term, A4, is equal to 123. So let's capture that. So they let us know that A1 is equal to 41 over 9, and A4 is 123. We also know that the general form for a geometric sequence is a sub n equal to a1 times r to the n minus 1. So in our example, we have the 123, which is the fourth term. We also have the first term. So I'm going to rewrite A4 using this general formula. So I'm going to have A4, I'm replacing n with 4, is going to equal the first term, which is equal to 41 over 9, times r to the third power. Replacing A4 with 123, we would have the following. So 123 is equal to 41 divided by 9 times r to the third power. And now we can solve for r. Oh, that's supposed to be 41 over 9. So I'm going to multiply both sides by 9 over 41. So I'll have 9 over 41 times 123. And that's going to equal r cubed. And so we can use our ALEKS calculator to do that computation. But I do notice that 41 does go into 123 3 times, but you can use the calculator to do it as well. So you would have 9 times 123 divided by 41. Oops, I hit 42. So I hit undo to fix that. So you get r cubed is 27, and therefore r is equal to 3. All right, so now that we have r, we can go ahead and answer the original question, which was, tell us what's the eighth term, because we have A1. So our general form for our equation now, we have a wonderful form, enclosed form. It's going to be A sub n is equal to A1 times r to the n minus 1. And so we just love that we can just have that general form once we solve for or know our values for A1 and for r. So we have A sub n is equal to A1, and this is all raised to the n minus 1. So now we can find the eighth value. So it's A sub 8 is equal to A1, which in our particular case was equal to 20, what was A1 equal to? 41 over 9, because they give it to us. So 41 over 9 times r, which was 3 to the second power. And 3 to the second power is 9. So then these are going to cancel. So 3 squared and 9 will cancel, and we'll find out that our 41 is our eighth term. You can think of this as almost 2 equations and 2 unknowns. And the 2 equations are generated by knowing the fact that A sub n is A1 r to the n minus 1. So that generated one equation. A4 is equal to 41 ninths r cubed, but once we plugged in the 123, we didn't have two unknowns, we just had r. And then we can go back and find out what a sub 8 is, because now once you know r and once you know a1, so once you know the first term and the ratio, common ratio, then you can find any value. Oh my goodness. I think this might be a sign. Let's see what I did wrong. So the r equal to 3 was correct. I found my error, and I thought maybe if I typed it a little bit better. So I have a8 is equal to a1 times r to the 7th. So I replace a1 with 41/9. I'm not sure why I have this long guy here. I'm not sure what I did there. Oh well, anyway, 41/9. I'm not sure why I have it all 3/7 like that, but that's okay. So now we can just use the Alex calculator. Whether I have the division bar underneath the 3 or only underneath the 41, it's equivalent. And the reason why it's equivalent, when you're multiplying fractions, you multiply the tops and bottoms, and you can think of 3 to the 7th as 3 to the 7th over 1. All right, so we're just going to plug that in, even though I know that 3 to the 7th is going to equal a value and 9 is 3 squared, but most students would not try to simplify 3 to the 7th over 3 squared as 3 to the 5th. So I'm just going to do it the way you would, which is 41 divided by 9 times 3 to the 7th. I think I somehow let my 7 probably look like a, I don't know what I did. Anyway, maybe my 7 looked like a 2 and I canceled it and had 3 squared and 9. But anyway, so the answer should be 99/63. So let's check. Perfect. All right, so then let's do the next one. So we'll clear our drawings and do the next one. So it says, for a given geometric sequence, the common ratio r is equal to -5, and the 12th term, A12, is 29. Find the 16th term. So in this case, again, we're given r, and we're also given the 12th term. So we have r is equal to -5, and then we also know that A12 is equal to 29. And now what we're going to do is use the general form for the given value where we know that A12 was 29 to help us solve for our A1. So A12 can also be written this way. A sub 12 is equal to A1 times the common ratio raised to the 12 minus 1. And so when we raise that to the 12 minus 1, that's going to give us an 11. And then we're going to replace A12 with its value. And we're also going to replace R with its value. And that will allow us to solve for A1. So let's plug in A12, which is 29. And that's going to equal A1 times -5 to the 11th power. And since it's negative, I want to make sure that I put that in parentheses. And then when we solve for A1 by dividing both sides by -5 to the 11th. So since 29 doesn't go into 5, I'm not going to try to rewrite that as a decimal or plug it into the calculator. I'm just going to leave it in that form. So I'm going to leave it as 29 over -5 to the 11th. And since I have -5 raised to an odd power, then I know my answer is going to be negative. So I'm going to capture that negative in front of the 29. So now I know that A1 is -29 over 5 to the 11th power. And so now that I have my value for A1, then I can compute any value because I have A1 and R. So then I have A sub n is going to equal A1 times R to the n minus 1. And now I can figure out A16. So A16 is going to equal A1, which is -29 over 5 to the 11th, times R, which is -5. Oh, wait a moment, I captured that minus already, sorry. Oh, I erased something over here. I don't know what got erased. But let's see if I hit the undo button. Oh, that's what got erased. I just want to get rid of this minus. It got rid of that 11 for whatever reason. I don't know why. Perfect. Okay, now I got it pushed back. All right, super. And then R is equal to -5 to the 11th. Maybe I should have kept it -5. Yeah, I think I should. I should have just kept it -5 because when I put in the R, it's also negative. Yeah, let's just do that. So I don't think it's going to let me erase that. So I'm just going to scratch it out. And I'm going to keep that -5. Because then I'll have the same base. And so now I'm going to have -5 to what power? To the 15th. It's always one less. So since we were looking for 16, this is always one less. So now I have -5 to the 15th and -5 to the 11th. So I have the same base. I'm going to subtract the exponents. And so I'm going to get A16 is going to be 29 times -5 to the 4th. And we can plug that into the ALEKS calculator. It turns out -5, since it's raised to an even power, is going to be the same as 5 to the 4th. So it's just going to be 29 times 5 to the 4th. And so we get 18,125. Let's do one more because there's another case where they don't give you the R. They just give you two terms. So let's clear our drawings. And here's the case where they're giving us two terms. So they give us the 8th term, and they also are giving us the 11th term, and then they say, okay, now you got to find the 13th. And so we're going to introduce a new formula whenever they give you two terms that are not consecutive. And so if we take A8, that's equal to A1 times R to the 7th. And then A11, let's write that one first because since it's the larger one. That's going to be A1 times r to the 10th. And it turns out if you divide those two terms of the sequence, so if you take A11 divided by A8, it's equivalent to taking A1 r to the 8th. Oh dear, this should be in 10. So look what happens when we divide A11 by A8. We have A1 r to the 10th divided by A1 r to the 7th. The A1s cancel. And then I just have one variable, r to the 10th over r to the 7th. But that can be simplified by using the quotient rule when we have the same base. So we have r to the 10th over r to the 7th. That's going to give us r cubed. And so we have a to the 11th over a to the 8th is r cubed, but a to the 11th, not a to the 11th, excuse me, we have a11 over a8. So a11 is negative 22. So we know that that's equal to negative 22 divided by 11/4. And so when we do that division, we have r cubed is equal to negative 22 divided by 11/4. Well, it turns out if you take the denominator, this guy here, of 11/4, you're going to invert and multiply. So we have r cubed is equal to negative 22 times 11/4. I said times 11/4, but it should be times 4/11. And it turns out 11 goes into 22 negative 2 times. So you get negative 2 times 4, which gives you a negative 8. But if you did it on the ALEKS calculator and you did minus 22 divided by 11/4, it'll give you negative 8 as well. So you get negative 8 is equal to r cubed. And then if you raise that to the 1/3 power, or no, the cube root of 8 is equal to 2. And so the cube root of negative 8 is negative 2. So we have r is equal to negative 2. So whenever they give you two values, rather than giving you the ratio, or rather than giving you A1, if they just give you two values for non-consecutive terms of the geometric sequence, you just divide. And when you divide, it turns out if you take 11 minus 8, you're going to get r cubed. I mean, you're going to get an exponent of 3. So if they had given you A12 and A5, you would just do what's 12 minus 5, that's 7. So I know the ratio of those two is going to give me r to the 12 minus 5, which is 7. And then I just plug in the numbers and say that's r to the 7th, and then I can solve for r. So once I have r, then I can use the values to determine A1. So when I say the values, I mean the values of the two terms that they gave you. So they gave us negative 22 and 11/4. So I'm going to pick this one because negative 22 is a little bit neater to play around with than 11/4. So I'm going to rewrite A11 using the general form. So I know that A11 is equal to A1 times R raised to the 10th power. And A11 is just equal to minus 22. Let me just move this over a little bit so it lines up. So I have minus 22 is equal to A1, which we don't know, times negative 2 to the 10th power. And then when I divide both sides by negative 2 to the 10th, I will be able to solve for A1. So I get A1 is equal to negative 22 divided by negative 2 to the 10th. And then on this side, it'll cancel when I divide by negative 2 to the 10th. Once I know A1 and R, I can find A13. So A13 is going to equal to A1, which is equal to negative 22 divided by negative 2 to the 10th, times R. R was equal to negative 2 to the 12th power. And the reason why it's to the 12th power, because 13 minus 1 is 12. So I have negative 2 to the 10th, and then I have negative 2 to the 12th. That's going to cancel and just leave me with negative 2 squared. And negative 2 squared is equal to 4. So I'm going to get 4 times negative 22, which is a negative 88. And sure enough, if you use the ALEKS calculator, and you take negative 22 times minus 2. I don't know if it'll let you put in something that big. So I'm just writing down exactly what I have without canceling. Yeah, it gives you negative 88. So you know what? You can just use a calculator. So you get negative 88 for A13. So I hope this movie on finding a specific term of a geometric sequence given two values is helpful.